Welcome back to Python programming from beginner to programmer. So we're in the middle of discussing or learning how to use Python to drive SQLite commands to gain access to the database. And we've come to the part where we discuss using SQL commands to perform multiple table accessing. So in this case, what we are trying to do is that information resides on two or more tables. Let's just look at two tables. And there are some kind of connections because of primary key and foreign key usages. And we are supposed to align them, align the primary key values to the foreign key values so that it makes business sense, right? And what we are trying to do here is to understand cross join and inner join because we learned in earlier video segments that we can perform these alignments using inner join. And also there is this cross join. So it sounds confusing, but we learned last time that cross join is a bit like union of all possible combinations of the rows. And inner join is the intersection of uh, the rows, that means a subset of the rows from both tables. And it is actually also a subset of the cross-joined table result. And we learned last time from the SQL command sessions that we simply just say cross-join table 1, whether to re-alias it as T1 or T2 or not is up to us. We cross-join the two tables, and we also learned that just putting a comma gives us the effect of cross-join. So whenever we are trying to express the real intention of cross-joining, we put in the word cross-join. And whenever we are just trying to, you know, kind of because of convenience, we put the two tables, make them available for the select to select, then we just don't mention cross join. So both syntax gave the same output. And to get this done, we will be using a new test database. So I'm going to copy and paste in this test01 database. Don't worry, it's really something simple. It's just the same as test1 and test2 like this. So we will have two tables in test01 database. Test1 will have two rows like this. Test2 will have three rows. So maybe as an exercise, I leave it to you to create these two tables. But just to guide you a little bit, let me double click on this. We have this new table here, test1, very simple schema. ID is an integer, name and year, ID and year are integers, name is a text. And the data is just two rows like this, very simple. Okay, you can just manually type them in. And test2, same thing. Okay, so except I make amount float just to simulate some sort of like transaction. Yeah, so and the name need not be the person's name, can be place, venue, location, and so on. So the data for test2 will be exactly what we have seen on screen here. So now we would like to perform cross join using Python to access it. Perform cross join. The idea is this crossed with test2, test1 crossed with test2, we get every row will be matched with every other row in test2, right? And then second row, we will have Bill, and then Bill will match with Kate, Mac, and Bill again. Yes, Bill and Bill. So it doesn't care. It just basically do a mechanical cross product, right? We learned this already. So now what's the effect and how do we do that in Python? That's what we are after. So let's go back to our spider over here and create a new script. So we'll copy from our earlier three block setup. So we have the yellow block to connect to the database, and we like to now change it. We need to change it to test01 because if we use the account database, and cross with itself, it's really huge, and we begin to lose track of what is going on, right? So to understand the operation of cross join is actually much better if we use a smallish database like 2 row by 3 rows. So in this case, we open it up and then we close it. So we are done with these 2 blocks. In the middle, what we want to do is to basically perform a cross join, right? Where's my cross join? So all I need to do is to select, because we are reading out, right, all the columns from test1 as T1, cross join with test2 as T2. All right, that's it. And then we just want to see it. We can also do it here just to convince ourselves. Select everything from test1, right, as T1. Um, let's just change it to V1, all right, just so that it's very clear cut visually that it is from the selection without using cross join. Okay. Select from, I would like to say from, where are we selecting it from? From this table, yeah. Okay, good. So I think we are ready. We did not have a where condition, so it means it will really return us the entire cross product. If we have a where, it will filter off certain rows, right, based on the content and behavior of the rows. So let's run this and we'll be able to see two exactly, or we expect to see two exactly same table, need not arrange in the same order, but they all have the same content as far as the entire table is concerned. And we also expect the columns to be 1 first and 2, except the first table has a T and the second table has a V. Okay, let's do it and see. Okay, what's going on here? Now, what is going on here is that yeah, because we just simply print all rows, so the entire tuple is just kind of joined with entire and the next tuple and keeps going. But this is the first row: Anna with Kate, and then Anna with Mac, and then Anna with Bill. Yeah, and then Bill with, fortunately, is quite handy here. Bill and Kate, Bill and Mac, Bill and Bill. So basically a listing of everything. Second table, we have Anna and Anna, Anna and Kate, Anna and Mac, Anna and Bill. So that's correct. Bill and Kate, Bill and Mac, Bill and Bill. Now, I did say that the rows need not be sorted or presented in the same order because they are actually different operations. But in this case, we end up a bit lucky, but do not depend on this because there is no documentation that assures us that whether we use cross join or comma itself will return us exactly the same order in terms of the rows. So don't depend on this expectation. And because we didn't erase our cursor.description, we end up seeing that as well. So this cursor, this description will refer to the most recent operation of select. So we get ID, name, and year, and then ID, name, and amount. So that obviously ID, name, and amount came from the second table, V2. Now we also see that the dot description didn't give us the V1, V2. All right, it gives us the original. So the as something did not come true. We label them V1, V2, but that is not very useful. All right, and basically in the dot description, we lost that information. Okay, so that is for using cross join. Using cross join. What if on the same table, because now we understood these two test one and test two tables. What if on the same table we don't use cross join, we use inner join? Now inner join, as we understood, is actually a proper subset within a cross join output. So the inner join will return if we inner join name versus name, name equal name, on name, right? On name means that columns data will be aligned row wise with the next table's column data. So if we do that, then Anna matches nobody, Bill matches Bill, Kate and Matt also match nobody. So they will be dropped out the moment they cannot be matched with anybody else in the other table. So only those that are common will be matched. So what do we expect? We expect a single row to be returned because we issue this joining instruction as um, on, right? On t1.name equal to t2.name. On the other hand, if we insist that t1.name is, that means on t1.name is equal to something else, like I don't know, the equal to year, then nothing will match and we will not get any uh, output. So the syntax is pretty much the same. So select all the columns that we want from table 1 as T1. Instead of cross join, we say inner join. And we learned in previous SQL video segments that this form of aligning the foreign key, that means test2, let's say this is a foreign key, uses test1, the defining primary key. This form of equating primary key from one table to the foreign key of another table, because they contain the same or similar kind of content, is very common, especially with customer ID, customer code, and all that. So where such situations occur, we should just use inner join. Now, in this case, let's try to just make a copy of it and copy from our previous select statements and modify from there. Okay. So over here, we have select inner join. All right. First of all, select everything from test1 as T1, inner join, right? Inner join, test2 as T2, on, and this is important, you must have an on, right? Otherwise it doesn't make sense. On T1 name equal to T2 name, and that is the first test. We would also like to perform this uh, test on different, literally on different column where we now align the ID, right? So if we align name, we expect one row. What happens if we align by ID? Let's just run it and see, and we actually don't need the description anymore. All right, let's run it and see. Well, it would be nice if we have some spacing here. Okay, then what happens is, whoa, did I type something wrong? No such column, T2 ID. Yeah, okay. Why is that so? T2 dot, oh, because I beg your pardon, we should type in the T2. Okay, let's run it and see. Okay, so first result is not surprising. We expected only one row, right? Because only one row matches both the on T1 name, T2 name condition. The second select using inner join, we find that there are two rows. So Anna matches with Kate. Why? Because the IDs are the same, 1 versus 1. Bill matches with Mac. Why? Because 2 is the same as 2. Yeah. So the equality test here ensures that they are kind of like, to human, it's a line, right? Where the numbers are equal, where the values are equal. So this is great because inner join says that inner join on the columns, right? So once you get used to this, it doesn't look so confusing anymore. It's like, of course, one table inner join with another table, but on which columns? Because they may not be on the same columns. So just write this out will do. Yeah. Okay. So this is what we're going to do with the demonstration on cross join and inner join. See you in the next video segment.